Hello and welcome back to Having Fun Repairs. We're going to come back to the FC Twin because I noticed something the other day when the kids were playing I wanted to point out. Hit that reset button real quick and then look at the logo and look at that video quality and notice that there's something not quite right with it, even with the characters. Now I expect it to be low quality because it is a composite video, but I think that there's an issue with the PPU or the modulator IC that's used for the composite video. So we're going to try to do one and potentially two things. One, we're going to try to repair the composite signal, and then secondary to that, we're going to try to make the system RGB out for composite video, or excuse me, component video going to the TV. And I'll show you what I mean by all that here in a little bit. Alright, so the other thing I want to point out is it doesn't appear to be with the NES side of the software, as the picture quality seems much better. It's just on the Super NES side. You can see all the weirdness. Colors not lining up. Something in the video is not syncing correctly, or maybe the signal's just not quite there. You also have this band that's running through the center. So I'll do typical things that I've shown in the past, like cleaning the cartridge connector out, cleaning around the board. But I got a feeling that it's not going to be with the what's modulating your RGB signal onto a composite cable. So more than likely it's not going to be this processor. Let me turn on the light. It's way back here, that IC. But we will look at that a little bit later on. It's more than likely going to be on this board right here. But I'll do all the cleaning off camera. It's not worth showing that again. And then we'll go into further troubleshooting. So cleaning done, still the same issue. And just in case you're curious, I tried with a different Super Nintendo game other than the Donkey Kong one, same results. Now while I was cleaning, I did run a small index card through here just to check the gapping, and it's really tight. Oh, I'm on the Nintendo side. Let me go to this side. Here we go. You do have, it's pretty tight on the left side of the cartridge slot, but over here on the right side is a lot looser. So I'm going to do that little trick that my man Vince showed in one of his videos and try to use my tweezers to bend these back out to make that connection closer, see what that does. However, even that resolves the composite video. There's still more I'm going to do to this console. I want to fix a lot of this factory issues I'm seeing, like these capacitors with long leads. They need to be shortened up and actually put on the board. I noticed on this connector when I took the hot melt glue off that a lot of the pins were not soldered on very well. I'm going to fix all that. Like I said, the ultimate idea I'd like to be able to do is, after repairing the composite video, is to make component video signal out of this console, because I do know that I can pull RGB off of the modulation chip back here, or the chip that modulates for a composite video. But for reference, you know, if I mess up anything, I went ahead and labeled these chips. This TC-T975 is the APU, the 978 is the CPU, and the 976 is the PPU. So our audio processing unit, picture processing, computer processing. You know, nowadays modern consoles, these two are at least combined onto the same semiconductors per se, the same chipset. But I'm gonna pull out these things, test again, see what happens. Do that off camera. Alright, so pulling out the pins didn't help it out. You can see a lot worse now here, especially when the title scrolls. You see that band coming up, you see all that video quality, and then it gets good after a second, but that band remains. So what next? What next is actually going through the console and doing some things. I want to show you real quick. Let me pause and get this cartridge. Alright, cartridge out, light back on. So I went ahead and traced out from the, I kept calling it a modulator. It's called an RGB encoder actually, but there is a circuitry or an IC. Ooh, it actually gets a little hot. We'll take a look at that as well. There is inside of this IC here, there is a modulation circuitry. It takes your RGB signal and modulates it onto there, but it's called an RGB encoder. I should have specified that better. I traced out the RGB signal, so here goes that RGB encoder. Pin 1, there goes a dot, it's a ground across there. 2 is your RN, 3 is GN, 4 is BN, and then your out's on the other side. And then what I did is I traced those out to each pin, coming from this side here to over here, and determined that this is R, B, that's G. If you can't tell, the soldering quality on this connector is pretty terrible. That's something I will address. As well as that, I traced it all the way through, pins onto the other side up here. Trace it through this board and traced them all down and around to TCT975, the PPU, and determine that those signals come up on this side. Just through a continuity check. We're going to throw this up on a scope, but there are several things I'm going to do before. Well, we'll look at the scope first, but then there's several things we're going to do after. If I was to orient this like this, which is how it's put in the board, you see the dots right there, bottom left corner. Bottom left corner is where that dot's at. Obviously that coincides with pin 1, but because I didn't want to count out all the pins, I just labeled on this side where I found them. 1, 2, 3, 4, 5. R went to 5. G went to 4, and B went to 3. So next thing we're going to do is throw these signals up on an oscilloscope. Just see what they look like. See if they look clean. See if they look dirty. See what's going on with them. And I'll come back and try to show you that here in a second. All right. Got the video going. I got my oscilloscope hooked up. First thing I want to do is test RN. And that came from pin 2, the RGB encoder. And then that should be, we go across the board, should be this first line here. If I can get this to focus. A pin here. Oh, sorry, no, here. And we can begin to see it show up on the oscilloscope. I want to hit auto real quick. go. And I want to just do a single sweep of this. Come on. There we go. So I've captured it. Let's look at this video signal. And I'll turn off the flashlight. There we go. So you can see the signal is repeating itself. That specific waveform. I want to expand it out a bit. Let's go this way first. And just look at those individual highs and lows. If I'm being honest, my newborn's being a bit loud. I'm not really liking what I'm seeing here. The signals don't look too good. It's also the fall characteristic through here. That's a little weird. I expect to see things like this, and I expect to see kind of like a flat top all the way across. This is probably just where it kicked in real quick and it came back down. So I imagine I would see something like that. The fact that this right here and this right here isn't uniform is a bit concerning. And that's probably just where the video came in and out real quick again. Just that one waveform. Again, since I do have a... It could have been where that waveform disappeared and came back up again, though. But there is definitely kind of weird. Let's take a look at see, that was R. Let's take a look at G. Turn the flashlight back on. So G came out of pin 3 of the RGB encoder. Pin 3 should show up right here. Alright, so this should be our, let's see, R, that should be G. You can see that come in. Not many greens there. Let's see what happens. Pretty interesting. I wonder what happens when I change my seconds per division. So yeah, nice. I really wish I had a test cartridge to actually just do each specific color. That would be great. Then I could actually see what the square waves look like without all this other stuff in between. I won't see that square wave for a second here. I think it's after this loops through. A lot of green information on the screen right now. Yeah, you see that square wave? Happens right at the start when the screen goes black. Which makes me wonder what happened if I just remove the cartridge. Let me do that for a second. So I went back through just on our waveform. You know, well, you can see where this signal is being based off of what's going on the screen. The waveform was changing. Well, I went back through and paused, run stopped right at when the square waves were just you know, as picture perfect as possible. And you can definitely see a hiccup somewhere around here when that signal is off. I think that's an area to be concerned of. I'm going to do the same thing with G, and then we'll move to B and check B in. So let me go and capture G real quick. So with G, see that little megaphone that turns soft music thing? It's oscillating. That signal's oscillating at the same time that thing turns around. And you can see more green come in. You see how that waveform changes. I think that's pretty unique. So you can definitely tell that that specific signal changes based upon what's going on that screen and the colors that are presented on there. Again, I'm going to capture that square wave for that signal coming in, and we'll take a look at it. Alright, here we go. Same square wave, same spot. Now I'm wondering if this is just coming from the sync or something else. Maybe it's the sync pulse or something that I'm capturing on here. I don't know. Somebody smarter than me should be able to tell me. But again, that doesn't look right to me. Could be an indication of maybe the PPU going bad or something. I'm not too sure. Alright, we'll do the same thing for, say we've done R, G, now we need to do B. So I'll be right back as soon as I got the probe on B. So with B going in, again, comparison. And I'll try to capture that square wave again. Just give me a second for this to cycle back through. Alright, so capture that square wave again, and you're seeing that same weirdness at the bottom. So again, I don't know. Look, it's super bad over here. Let's scroll over. Wrong one. Remember, the same signal repeating. It's capturing it over 1.08 milliseconds. Oh, sorry, that's the position. 2.5 microseconds. We got a very interesting spike in that signal over that time frame captured right there. And it's not showing up on every single one, but it did show up during that period of time right there on that signal. Pretty interesting. You do a comparison. These two look similar. Those two look similar. That one doesn't. So if I look at the bottom, these should have been the same as. Well, they probably should have all been the same. But then again, I don't know. To me, this is telling me that there's probably an issue with the PPU. You know, if the PPU is going bad, maybe it's power getting to the PPU as well. I can tell you that this heat sink back here, and it is really getting hot, as it should if it's displacing heat from whatever MOSFET is powering this device. Super hot. But regardless, I think what I'm going to do is go ahead and tear down this console, fix the components that at whoever manufactured it that were put in just really janky. Fixed up that ribbon cable there, and then probably reflow the PPU and see what happens. Hopefully I don't break it. If it doesn't get any better, it doesn't get any better, but that's okay. We'll move on to trying to get composite video out of here, even if component video is bad. You know, maybe later on down the road, probably replace this MOSFET, because like I said, it's getting hot. Might have to replace this PPU, but you know, I don't think you can really find these components online somewhere. I have to do a bit of research, but we'll see what we can do. Alright, so that was about an hour's worth of work. I ended up just stopping the video while I was cleaning, because there's really no point in just recording all that. But as you noticed, went through with the MOSFET sitting here, hit up these connectors, hit up this cartridge slot for the NES, cartridge slot for the Super Nintendo. Fully seated these caps that were just loosely tacked to the board. You probably wonder why this crystal is still not seated. I decided not to mess with that because I know crystals are very delicate. Temperature, hitting them is, you know, even tapping them can be an issue. And if you lose crystal, well, your game is messed up until you get it replaced. So I decided I'd just rather not try to get this seated in the board. I think it's too much of a risk, so I'm going to leave that the way it is. But everything else has been touched up and cleaned and seated. Now I'm going to reflow the PPU, but before I do that, I'd like to set it aside and focus instead and allow all that alcohol to evaporate off on these two LEDs that they have attached here, because it really doesn't make any sense to have such long leads. I mean, just a small tug and you short these things out. And you really should have heat shrink over this. So what I'm going to do is I'm going to trim up these leads and take these wires off and resolder them on and put some heat shrink down them. So that way there's no risk of the leads shorting out to each other. That's definitely what I'm going to do next. Alright, now with that guy out of the way, we can focus on reflowing this chip right here. ESD strap on real quick before I start touching things. Now, when it comes to reflowing, a couple of precautions I make is one, cap and tape. so when I'm applying heat, it's not getting onto overheating components or plastics in the surrounding area. And I'll keep my nozzle pretty close to this chip. Okay. Also don't want to overheat this chip. I only want to get the area hot enough to remelt or liquefy the solder itself. And then as soon as I see that nice sheen, I'm going to pull the heat away. Now, I will put pressure on top of this IC, but only because of two reasons. One, this is not a BGA style chip. Here, I'll show you something as an example. Here goes a reality synthesizer from a PlayStation 3. Okay, I have a couple of these in stock from where I used to reflow or replace these on the PlayStation 3. You see these little fine ball solder points all underneath here. Okay, now if that solder was melted and I was putting pressure down on the top, you can imagine that you're going to be essentially squishing all these soldered points. Okay, now that in itself is not so bad, but when it's in a liquid state and you put pressure on top of an IC, and if you don't have the steadiest of hand, you run the risk of small, minute movements. And by doing so, you can actually bridge these connections down here. So I would never put direct pressure on top of a BGA. If I was reflowing or replacing one of these, I'd make sure that I could see it float into place and then maybe do a slight nudge, but never direct pressure on top. That's not how I would manage a BGA. With this right here, I have no issues doing direct pressure on top, provided that my hands are well supported, that I'm not moving around so much. And two, the second reason, other than the fact that it's not a BGA, is I will put pressure on here so long as this is already in a solid state, meaning it's already connected. I would not heat this up with my hot air gun, allow the solder points to liquefy, and then attempt to put pressure on the top. That is not the right time, because again, you run the risk of potentially moving and bridging all these soldering points or soldered joints, whatever you want to call them. So instead, what you could do if you were replacing an IC as such is you could use your hot air station and melt it, and you'll see it go into place, and then you'd pull your hot air station away. You allow all these soldered points to harden. You'll see that nice, you'll see the salt, if you look close, you can see the solder go back from a liquid to a solid. And then afterwards, you can put pressure on top and then flow once again to make sure that it's in the right spot. But only after it's in that solid state. So, I'm going to reflow this. Hot air gun set to 600. I'm going to turn 600 degrees Fahrenheit, that is. I'm going to turn airflow down to 45, and let's attempt to solder this or reflow it. Alright, with that now out of the way, I'm going to, and this cooled off, I'm going to test each one of these pins to make sure that they are connected and not free from the board. If they are, I'm going to touch everything back up with a soldering iron, just because I feel like that's an appropriate thing to do. But it's going to take me a minute to check all these, so bear with me for a second. Alright, all of them seem to be well adhered to the board, so no sense in me touching up any single one with a fine tip soldering iron. So now it's just really getting that thoroughly cleaned up, because that's rosin core flux I'm using, and if left on the board it could become corrosive itself, so it needs to be cleaned off. So that's what I'll be doing next. Alright, so somewhat put together. I haven't put that button back in. Still got to solder back up those LEDs, but do want to go ahead and give it a test. And no, still the weird colors. Poor picture quality. You still have, let me turn off the flashlight. You still have that weird vertical line right here. Of course, I got all the sound muted. You can see it goes all the way up through the center. So I'm thinking the PPU might be bad, or something else needs to be replaced. But I do want to try one other thing with that PPU before I give up on it and just go ahead and throw in composite component video, try to make a component video signal, so I get a replacement PPU. We'll go ahead and switch it up. Nintendo's still working just fine. No issue with that video quality on it. So let me get this turned back off, and I'll show you what's going through my head here in a second. So despite the not being able to get the composite video to work, we're going to go ahead and move along and try to make a component video. What I have here on the screen is that RGB encoder. It's on the back half of the FC Twin. Notice pins 1 through 12 down here on the bottom. Then you have R, G, and BN on pins 2, 3, and 4, as we previously saw. Those signals were taken to be encoded or modulated onto a carrier for your composite signal. Match 75 ohms out to your television set. But you can see here on pins 23, 22, and 21, you are presented the same signal from the opposite end. There's a VCC here on pin 12 that will come in handy. I believe that's a 5-volt VCC. I think I read it somewhere down at the bottom. Pin 12, pin 12. Here we go, 5 volts VCC. And what we are going to do is I purchased a THS 7316 DR 3-channel HD TV video amplifier, and the hope is that we can use it to pull off that RGB signal, provided some amplification, and send it out over a RCA connector to our TV. Alright. So here are those little 8-pin ICs. These I ordered from DigiKey. Came in an ESD safe package with some desiccant and a humidity indicator. This used to be blue, it's just been sitting out now, so that's the reason for that. I'd also ordered some off of Amazon, and they have a very similar marking on the top, but this didn't come in an ESD bag. This just came wrapped in bubble wrap. So the likelihood of these being damaged in transit, or especially since they are an ESD sensitive devices, is pretty high, so I won't be using those. Instead, I'll be using these right here. And here's essentially what I'm going to do. Here's a rough diagram of that RGB encoder. And I'm going to pick off pin 12, and after 12 you go 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 21 pins 21, pin 22, and pin 23. Even though I labeled them 4 across, that's just that way I don't forget when I'm looking at it and I can count down. R out will go to pin 3 of the next encoder. Let's see, pin 4 will go to pin 2, and pin 3 will go to pin 1, and we should output a nice strong signal on the other side. Off of each of these lines I'm going to build my own little PCB. We'll put in a 75 ohm drop down resistor to ground. Impedance match, obviously 75 ohms out to the RCA connector, so we have impedance matching to our television. The 5-volt signal will go into pin 4, and then ground will be tied to pin 5. We also will put in a 0.1 microfarad capacitor between our VCC and ground to prevent oscillation of this IC, and then a 22 microfarad capacitor to act as a filter cap to prevent interference from the 50 or 60 hertz signal. Essentially, our AC line in the UK or Europe, that AC line is 50 hertz. 240 volts, 50 hertz. In the US, 120 volts, 60 hertz. You want to make sure that you're filtering out this frequency from showing up on your DC line. So this is what I plan to build. These are a lot tinier than I thought they were going to be, but I think I'll be able to build a little circuit board to get this to work. Now this circuit board built and all the components put on place, it's going to be like mocking it up to see where is the best mounting place for it. And I think I'm going to mount it just right on top of these other components. Allow me to cut these leads relatively short and get them soldered onto that RGB encoder. And then I could put, more than likely, the output signal, although I'd like to get it on the back. That's pretty well populated. I'll probably put it out here towards the side somewhere for those video input for the component cables. So that's what I'm going to do next. I wanted to pause the recording for a second because, you know, thought keeping these things relatively close would be good, but I didn't think about the clearance requirements for the connector itself. So unfortunately, I'm going to have an extra hole, so I'm going to have to drill one out here, drill one out this way, and then move these two down one. Yeah, but you live and you learn. Okay, so extra hole to the side, now in there. Again, you live, you learn. Okay, first fire up. It's going to power the system and go through composite video. Yeah, I probably should have plugged in this first. Whatever. Okay. Throw in Donkey Kong Country. And hey, lights up. So, phone still works. Mute this for a second. Unmute it for a second. Yep. Sound still works. So let me pause this. Actually make sure that the Nintendo side is still good. LEDs and Nintendo side good. Alright, now let's try component video. Okay, first fire up for a component. Now I did smash the wires a little internally, shutting the clamshell. I should have paid better attention to that. But we'll see what happens. Check cables. And nothing. Let me take it to my bench, see if we are actually getting the component video signal. Okay, so 5 days have essentially passed since I attempted to use RGB to drive a component video signal. And little did I know I had a lot to learn, because RGB is not the same as red, green, and blue for YPb and PR. You actually have to learn how to encode those signals, or convert them, or encode them, decode them, in order to get that video format if you're going from RGB to component. Now, if you notice, there's been several changes to the circuit boards for the Yobo FC Twin console anyways. Many testing in and out of different things just to try to get a signal onto the TV through the previous circuit board. Little thing I developed caused the flex ribbon cables to break, and so I just went ahead and pulled all them out and soldered in a lot of wires just to allow for a more rigid and a fixed connection. And here's what I came up with, and here's the final diagram. So I kind of borrowed a little bit more from that first photo, at least this portion right through here. These components, that resistor, these transistors, this out, eliminating the capacitors. I didn't use those. Ignored everything up here. And essentially what we have is our RGB out, 1.7 volts DC a piece, going each under a 75 ohm load or pull down resistor, however you want to call it, not too sure which. I then feed the R out through 1k ohm resistor, G out through a 50 ohm resistor, and B out through a 2 kilo ohm resistor. Going to this NPN, tying them all together. Of course, you'll see that there's a 500 ohm resistor from collector to base, a 1k ohm resistor from emitter to base. The emitter's tied to ground, and then the collector comes out and goes this way. Here's where I pick off the R and G pre 75 ohm load or pull down resistor. I feed R out to a 10k pot, and I feed B out to a 10k pot as well. I tie those two together, and those are in line with this connector here with the collector of Q1. Of course, that's going to send R and B forgetting something. Well, it's the essentially what's on this line is feeding into one side of the resistor, and then my R signal and my B signal is fed into the other side of the potentiometer. I do my adjustments because this potentiometer, you got a third leg that comes off that potentiometer. That's then fed to, R is fed to Q2, B is fed to Q3, and this is how we develop our PR and PB. There's a 500 ohm resistor in between these two lines, and then I feed in 5 volts DC from this VCC here. It's also feeding our HD TV video amplifier. Feed that same 5 volt rail into the collector of each transistor, and so we get a bit of amplification of those signals, and then those are fed into pins 2 and pin 3 respectively of the S7316DR. Power wise, I've got my 5 volt rail, I got my ground rail tied to the same RGB encoder, the pins respectively from there. 0.1 microfarad and 22 microfarad capacitor as mentioned previously. And then I output, this amplifies again, approximately 3-ish volts, 4-ish, 5-ish, 6-ish volts. I'm not too sure, I'd have to check it with the multimeter. But it's amplified again. My Y out, Y, of course, it's going through its own 10K potentiometer, fed into pin 1. Should have mentioned that. And the other side of that pot I have tied to ground. So it's basically, I'm just trying to reduce the amount of, reduce that signal before it gets amplified here. That's kind of my control. And that's basically why I also went away from this design, is because all the control, my potentiometers and stuff, were essentially happening after the amplification phase. And so I found out that these potentiometers were just, they're very, this is a super saturated circuit at this time because of an amplified signal, and trying to control post amplification is not as good as doing it pre-amplifier. That's what I found out. So Y out, PR out, PB out, each going through a 75 ohm resistor and then to their RCA connector. Now we'll go over to TV so you can see exactly what I have. And here we go. There goes the video. See, my reds are reds, my blues are blues, my greens are greens. Actually, it's kind of got a pinkish tint to it right now, so at least the background sky, so I need to make a small adjustment. But just so you know, it is component in. This is not any tomfoolery. Let me turn on the light. The composite's not connected. Got my component cables feeding all the way into the back of the TV, even though I have both located here. Now here's that board, the circuit I built as mentioned on this built onto the PCB. There's where I connected all the wires as previously mentioned. Okay, so as far as those 10K pots, the adjustments, this is my luminescent adjustment. Let me see. Alright, this one is PR, or excuse me, R, adjusted potentiometer, the gain free amplifier for that. And this one is PB or blue. So when I say what I'm adjusting, at least now you have something to reference back to. My daughter is very animated right now. So there goes the picture. Let me see if I can kill the light. And I'll make these adjustments. First, the Y adjust. You'll see that the picture will brighten up substantially. And I found out that I have to turn that Y down to, not all the way down or I cut the video out. Pretty far down to get a good, really good image. See, too far down it cuts out because you're killing the sync as well on that Y out. Find it going a little darker is pretty much where it should be. Alright, now I'm going to mess with the R adjustment. See how it gets super red, super saturated. Going counterclockwise on this. Now we'll go the opposite way. Becomes less saturated and more into the grayscale with some slight blues because of the PB adjustment. So I know this is supposed to be red, that's supposed to be yellow. Obviously my greens, my background is supposed to be blue. Need to see that sky again to get a good image. There. See, that's too much red. Reduce that. Still got some blue there. That's good. In the sky. And now we'll do the other pot. See how it gets super blue? That's going clockwise. Now I'll go counterclockwise. You start to lose that blue out of everything. You'll see that the background of the sky, when it shows it again, it's actually kind of gray, no longer blue. See, now the sky's gray. I need to get that blue back in. But I don't want to oversaturate it. I mean, it's slightly oversaturated, but it's not bad. Let's see how this looks when it cycles back through. Took just a smidge of that blue back out. I want to see that sky. Yeah, it's too gray. Add a little bit more back in. Maybe just saturate the red a little bit more. I think that looks pretty good. All right, let's compare this to the. You see, there's no line, vertical line, none of that nonsense anymore. So I want to compare it to the composite video, just to give you something to look at, to compare it with. Let's see. Take out component. And man, what a huge difference. What a massive difference in video quality. I mean, the colors are a little bit better, kind of, on a composite. At least the greens are more greens and the blues are more blues, but that could also be because of how they're modulated to make that signal modulated together. And we're kind of doing that ourselves with the board that we built. Put the component back in. But yeah, I'm really happy with how this turned out. Really, really happy. Couldn't be happier. I mean, not even any funniness in there anymore. I'm really liking how that looks. It's so amazing, the difference. The real test is going to see if the NES side works with this setup. So I'm going to button everything up and stick it back together, and I'll be right back. Okay, here's everything hooked back up. I cut a little. I know it's not pretty. It slid back here so I can adjust those pots when needed, because I expect as the temperatures increase inside the gaming console, it's going to have an effect on the resistors and their values, those potentiometers and stuff. So I want to be able to at least have easy access to it. But anyways, I'm running it through composite right now.
Mario.
But I learned that the NES will not work with this mod, just like if you was to just hook up.
Hey, Daddy.
Just like as I heard several people doing the S-Video and VGA mods. But at least this one is fully my own. The board is hodgepodge from several other diagrams I saw, plus my own devices. But as you can see, the NES will not display. But Super NES works good. Switch it back over to component now, since I changed those cables out, and the picture quality is pretty much perfect. I mean, nice vibrant colors. They're a little bit brighter on the composite video, but that's probably just because the Luma is adjusted slightly higher. I like having it darker, so I have more rich colors. Well, I think this looks really good. I'm really impressed by this. The blues are blues, the greens are greens, the browns are browns. So, you know, I like it. Alright, a little bit of video play. Show that everything is working. Not sure if it's capturing the image quality correctly on here, but the reds are reds, the blues are blues, the greens are greens. And I think it looks pretty good. And then you could tweak the picture up if you must.
Daddy, look, it turns on.
Yeah, buddy.
I want to see it. Go. Hey. Oh.
Alright. I like it. Y'all like it?
Yeah, I want to see it. I want to watch it.
Yeah. Well, folks, I think I spent a total of 6 days, maybe 7, on that project. Learned a lot, and if you liked the video, if you liked how, you know, it's a little bit different, it's more of a modification than a repair, but if you liked the video, then give it a big old thumbs up, subscribe, and share. Of course, you know, you don't have to do any of that, but I would appreciate it. And have a good one. Peace.